I'm explaining the core issue. We're using Sklearn's AdditiveChi2Sampler for text classification. The problem is that some word counts are extremely high, causing a skewed data distribution. We need to figure out how this skew affects the sampler's performance and how to fix it. I'll unpack this question, okay? We're using a specific tool, AdditiveChi2Sampler, to speed up calculations in text classification. The data shows an imbalance. Some words appear far more often than others. The question asks how this affects AdditiveChi2Sampler and what we can do about it. This is a possible answer choice. It claims that the high word counts won't matter. AdditiveChi2Sampler will handle them fine. This option suggests that the high word counts will skew the results, making the sample unrepresentative of the data. This is a plausible problem. Here, a possible solution is proposed, using a log transformation. This mathematical trick reduces the effect of large values, potentially balancing the data. This option claims that AdditiveChi2Sampler automatically handles skewed data by reducing the impact of high values. We need to see if that's true. Let's break down the steps involved in answering this question. First, we understand AdditiveChi2Sampler. Second, we consider how the skewed data will influence results. Finally, we evaluate whether transformation helps. I will now explain the correct answers by examining the provided options. Options B and C are correct. Option B correctly points out the problem of skewed data leading to biased results. Option C suggests a correct mitigation strategy. The correct answers are B and C. I see a problem with skewed data. Imagine a bag of candies where most are red and only a few are other colors. This is similar to having some words, features, appear far more often than others in our text documents. This uneven distribution can cause issues for the AdditiveChi2Sampler, which is a tool we use to make calculations faster. Because of the uneven distribution, the most frequent words, those high-value features, will get-picked more often during sampling, making the approximation inaccurate. It's like only choosing red candies from the bag. You'll get a wrong idea of the total candy colors. The resulting approximation is skewed, not representing the actual data well, which leads to poor model performance. I can fix the issue using a logarithmic transformation, such as log 1 plus x, which shrinks the large values while making smaller values relatively larger. This makes the distribution less skewed. Think of it like shrinking the mountain of red candies to a small hill and making the small hills of other candies more prominent. This is absolutely true. The high-value features, or high-frequency words, will be overrepresented, leading to an imperfect approximation. This option is also correct. The log transformation helps even out the data, preventing the high-value features from dominating. This is false. While it handles sparse data, it doesn't automatically correct for skewed distributions. It still needs help. I'm tackling a problem using Sklearn's AdditiveChi2Sampler for approximating a kernel in a text classification task. My feature vector, representing word counts, has a skewed distribution because some features have extremely high values. I need to figure out how this skew affects the AdditiveChi2Sampler's performance and what I can do about it. Because of the skew, features with very high values will be picked much more often during the sampling process. This makes the kernel approximation less accurate, and my model might not perform well on new data. Think of it like this. If you're sampling opinions from a group where one opinion is overwhelmingly dominant, your sample might not reflect the diversity of views. I can use a logarithmic transformation, like log 1 plus x, to reduce the impact of extremely large values. This makes the data less skewed and improves the balance of features. The AdditiveChi2Sampler will then be less influenced by those overly dominant values, leading to a better kernel approximation. It's like turning down the volume on the loudest voices so I can hear the others better. That's incorrect. While AdditiveChi2Sampler works well with sparse data, it does not Automatically adjust for skewed distributions by giving lower weights to large values. The sampler is still affected by the skewed shape of the data. It's not a magic bullet that fixes everything. That's wrong. AdditiveChi2Sampler doesn't automatically deal with skewed data. High-value features will still have a big impact on the sampling process. I'm focusing on how uneven data affects the AdditiveChi2Sampler, a tool used for faster calculations in machine learning. Think of it like this: if you're trying to get the average height of a group, but a few giants are in the mix, the average won't reflect the typical height. Similarly, skewed data throws off the AdditiveChi2Sampler. This question tests your understanding of AdditiveChi2Sampler and how it handles imbalanced datasets. We'll examine how such issues influence the AdditiveChi2Sampler's performance and how we can deal with it. I'm looking at situations where your data is unbalanced. Some values appear much more frequently than others. For example, in a text analysis, some words might be super common, while others are quite rare. This imbalance is what we mean by skewed data. This unevenness can significantly influence the results of the AdditiveChi2Sampler, making the results not quite reflective of the whole dataset. This is a scikit-learn tool that helps speed up calculations when dealing with large datasets, specifically those dealing with positive numbers, such as word counts in a text classification problem. It approximates the chi-squared kernel function, which is useful for measuring the similarity between different data points. The AdditiveChi2Sampler tries to create a faster, simpler version of the chi-squared kernel, but it's susceptible to bias from skewed data, potentially leading to inaccurate results. I'm presenting a problem about using scikit-learn's AdditiveChi2Sampler for text classification. We're using word counts as features, but some features have extremely high values, creating a skewed distribution. The goal is to determine how this skew affects the AdditiveChi2Sampler's performance and how to fix it. We'll look at different options to understand what works and what doesn't. This statement is incorrect. I'm finding that AdditiveChi2Sampler, while designed for positive data like word counts, doesn't automatically correct for skewed data. The high values will still heavily influence the results. This statement is correct. I found that high-value features get sampled much more often, leading to a biased approximation of the kernel. The model will be less accurate due to this skewed sampling. This is a great idea. I've learned that applying a logarithmic transformation, such as log 1 plus x, helps compress the high values, making the distribution less skewed. This means the sampling process becomes more balanced, leading to a better kernel approximation. This is incorrect. While AdditiveChi2Sampler works well with sparse data, it does not automatically adjust for skewed distributions. It doesn't automatically reduce the influence of high-value features. The correct answers are indeed B and C because option B accurately describes the problem, and option C offers an effective solution. I agree. Option B explains why the problem happens, and option C provides a clear way to solve it using a logarithmic transformation, like adding 1 before taking the log to avoid issues with 0. I see a problem with skewed data, specifically a feature vector with high word counts. This means some words appear far more often than others, creating an imbalance. This imbalance is important because it can affect how a machine learning model learns. The core question is, how does this uneven distribution of word counts affect the performance of the AdditiveChi2Sampler, a tool we use to approximate kernels in machine learning? This sampler is like a shortcut to make calculations faster, but the skewed data might mislead it. This statement suggests that the AdditiveChi2Sampler ignores the skewed data. I disagree. It's untrue because the sampler's results are directly influenced by the data's shape. This option correctly points out that, with skewed data, frequently occurring words will dominate the sampling process. Think of it like a popularity contest. Words that appear often will overshadow those that don't. This leads to a biased representation of the data, affecting model accuracy. This is a valid solution. A logarithmic transformation, like log 1 plus x, compresses the range of high values, making the data distribution less skewed. It's like turning down the volume on the loud words, so quieter words get a fairer hearing. This balance leads to better results. This option is incorrect. The AdditiveChi2Sampler doesn't automatically adjust for skewed data. it simply doesn't have a built-in mechanism for compensating for this type of data imbalance. I'm talking about a specific function from the Sklearn library in Python. It's a tool that helps estimate a complex mathematical equation, the chi-squared kernel, more efficiently. It's used when you have lots of data points, like word counts in a text document. Think of it as a shortcut to get a good approximation without doing way too much computation. Because of the skewed data, AdditiveChi2Sampler is more likely to pick certain features over others. Imagine you're picking candies from a bag. If most candies are red, you're more likely to pick a red one, right? Similarly, in skewed data, features with extremely high values are picked more often during sampling, which can lead to an inaccurate representation. This is what I mean by biased sampling. This refers to data where some values are extremely large compared to others, creating an imbalance. It's like having a few giant trees in a forest with lots of small shrubs. The few huge trees dominate the overall shape of the forest. This imbalance impacts the efficiency and accuracy of mathematical tools like AdditiveChi2Sampler. This means we've reduced or lessened the effect of the skewed data. Using a technique like a logarithmic transformation, we make the giant values in our forest smaller, making the distribution of tree sizes more even. This way, we improve the fairness and accuracy in the sampling process. When you have skewed data, it throws off AdditiveChi2Sampler. The extreme values will be disproportionately represented during the sampling. It's like trying to get a fair estimate of tree sizes from the forest example I just mentioned. If you only look at the giant trees, you'll have a severely inaccurate picture of the forest's tree sizes. This is the core problem. We're analyzing how a skewed distribution of data affects the AdditiveChi2Sampler and how we might fix the problem. This is a mathematical technique to reduce skew in data. Instead of using the original values, we replace them with their logarithms. For example, if a word appears 1,000 times, we take its logarithm, approximately 6.9, significantly reducing its impact compared to the original count. This helps balance the feature values and makes the data more suitable for AdditiveChi2Sampler.